So once we know how y and x move together, we have that slope term of the first derivative. What do we do next? Well, typically we think of y as something we're trying to get an extreme value for. It could be, say, profits, in which case you want to maximize those. Or it could be sort of average total cost, in which case you might want to minimize it, average total. This sort of activity, and you might have constraints, but we're going to look at finding these extreme values in the general case. So what we're looking at is going to be something that might move like this. We could have x on this axis and y here, and we've got some relationship that might be U-shaped like this. So this is y is some function of x. And what we're looking at is, what is this lowest value here? So we're minimizing y, and this would be some sort of lower bound on y. And that's what our target is. Well, that occurs at some value of x that we're trying to find. So if you find x, you wind up finding the minimum value of y. Another possibility is a similar idea, but the shape is a bit different. You have x and you have y. And for some reason, this function goes up and then declines. That's y equals some f of x. And what we're trying to do is find the maximum value of y. And that means, what's the value of x that will maximize the value of y? In both of those cases, you'll notice that you've got a slope down, flattens out, and then you get this horizontal area, and then it starts to go up again. So that would say that the minimum value is where the slope is equal to 0, or dy dx, which is slope, is equal to 0. And if you were to look at the curve that goes up and then goes down, you'll see it's positive, flattens out, and it becomes negative. And so where the slope is equal to 0 is where you're going to find that x that you want. And that is what we're looking for. So a lot of it is focused on the idea of the slope is 0. The slope is 0 tells us when things move in an opposite direction as to where they were previously. And that's what we'll be looking at next. So the baseline idea is to set the slope, dy dx, equal to 0. And I thought what I might do is give a particular example that may or may not have resonance with you, but it does create some problems in politics. It also has meaning in businesses. I want to start with the idea that t, little t, is equal to the tax rate. This is the proportion paid in taxes. And we all have our taxes to pay. Hopefully you have income enough to pay. So it's the proportion paid in taxes. And this tax rate is somewhere between 0 and 1. Remember, tax rates can't be over 100%. Well, actually, they can. It happened in Sweden once. That'll convince you never to work again. So it's between 0 and 1. And then I'm going to write capital TR is equal to tax revenue. Okay, so we have tax rate and we have the tax revenue. One of the more interesting phenomena in the politics of taxes is called the Laffer curve. And it's really rather simple to understand, at least I think it is. So if on this axis we have the tax rate, which we adjust, and that influences tax revenue, and we have 0 as a possibility and 1 as a possibility, this is, remember, 100% tax rate, we have the following propositions that are true. If the tax rate is 0, then by definition you collect no tax revenue from it. We can also be pretty certain that if the tax rate is 100%, nobody's going to bother working because you don't keep anything. And so what we have is something that looks like this, that tax rates are some function of tax revenue. And at both 0 and 100%, we can be absolutely certain that there won't be any tax revenue whatsoever. But at some intermediate value, I'm going to call this little t star, you get the maximum possible tax revenue. We'll call that TR star. And the debates are fascinating in this area. You have some people who argue, and it makes a lot of sense, that if we started at some value for the tax revenue, or the tax rate, pardon me, you might see something like this. So here we have our tax rate, here we have our tax revenue, and let's suppose we're starting at a point here, right? And we're not worried about the axis so much, but you have some people who will argue that if you lower the tax rate, so we start with our tax rate here, this is going to be T0, and our tax revenue TR0. If you start at this point and you lower the tax rate, so you're going this way with the tax rate, tax revenue will go up. So tax rate down, tax revenue up, that would give you a curve that looks like this. So that would say if the tax rate is too high, tax revenue is 0, and that makes a lot of sense. But that same linear pattern also says if the tax rate is 0, remember this is the tax rate 0 down here, then the tax revenue is really, really high. An upper bound is made on that. So while the lower part of this curve makes sense, that if the tax rate is too high, you're going to see tax revenue go down, the extreme case up here doesn't make much sense at all. We have other groups of people who argue that raising the tax rate, moving to the right, will cause tax revenue to go up. And the linear version of that would say that, well, let's see, a 0 tax rate means 0 tax revenue, and this makes a lot of sense. However, it also means if you continue going up with the tax rates, you'll have an increase in tax revenue. Well, that makes no sense because that says if you're way out here, say 110% tax rate, you have a huge amount of tax revenue. But why would anybody work when they have to pay not only all the income in taxes, but also some of their wealth? So both of these arguments have some sense. Both of them have some weak points. But what we have is this idea that they can make sense or not make sense. And the question then becomes, okay, what will happen given where we are to tax revenues if we change the tax rate in some particular direction? That's going to be the subject of the next video.